Welcome to my YouTube channel Cognara. I'm Michael, your science and technology educator. Today, we are going to explore one of the most fascinating ideas humanity has ever imagined, not as fantasy or science fiction, but as a serious scientific question that real physicists have spent decades trying to understand. We are going to talk about time travel, what science actually says about it, what experiments have already shown us, and why the truth is far more subtle and surprising than movies ever suggest. When most people think about time travel, they imagine stepping into a machine, pressing a button, and instantly appearing in the past or the future. They picture dramatic scenes, changing history, meeting the younger self, or jumping thousands of years ahead to see what the world becomes. These images feel powerful because they touch something deep inside us, a desire to revisit moments we regret or to glimpse a future we cannot yet imagine. But in real science, time travel is not a single idea. It is a collection of strange and beautiful consequences that emerge from how time itself actually works. To understand this, we need to start with a simple truth that feels uncomfortable at first. Time does not flow the same way for everyone. This is not philosophy. This is physics. In 1905, Albert Einstein showed that time is not an absolute background ticking away evenly for the entire universe. Instead, time stretches and slows depending on how fast you move and how strong gravity is around you. This idea is called relativity, and it has been tested so many times that modern technology literally depends on it. When a clock moves very fast, or sits in a strong gravitational field, it ticks more slowly compared to a clock that is still or farther away from gravity. This effect is tiny at everyday speeds, but it becomes dramatic as you approach the speed of light or the gravity of massive objects like black holes. This means that time travel to the future is not theoretical. It is already real. Astronauts on the International Space Station age slightly more slowly than people on Earth because they are moving faster and experiencing weaker gravity. The difference is tiny, only fractions of a second, but it has been measured with atomic clocks that are so precise they lose less than 1 second in millions of years. If someone could travel near the speed of light for a long journey and then return to Earth, they would come back younger than everyone they left behind. For them, only a few years might pass, while decades or centuries pass on Earth. This is not science fiction. This is a direct prediction of Einstein's equations. So in a very real sense, we already know how to travel into the future. The only problem is that the energy required is far beyond anything humanity can currently produce. Traveling into the past is where things become far more complicated. The equations of general relativity allow for strange solutions called closed time-like curves, which are paths through space-time that loop back onto themselves. In theory, these paths could allow an object to return to an earlier moment in time. Some solutions involve rotating universes, infinitely long spinning cylinders, or exotic structures known as wormholes, which connect two distant points in space-time. If one end of a wormhole experienced time differently from the other, it could, in principle, act as a time machine. But every one of these ideas requires conditions that may not be physically possible. Wormholes, if they exist at all, would collapse instantly unless they were held open by exotic matter with negative energy. So far, no known substance in the universe behaves this way in the quantities required. Even more troubling are the paradoxes. The most famous one is the grandfather paradox. If you traveled back in time and prevented your grandfather from meeting your grandmother, you would never be born. But if you were never born, you could not go back in time to stop the meeting. The logic collapses in on itself. Some physicists suggest that the universe prevents paradoxes from happening through consistency rules, where events always unfold in a self-consistent way, no matter what a time traveler tries to change. Others propose that traveling to the past would create a new branch of reality, forming a parallel timeline instead of altering the original one. These ideas are mathematically interesting, but none of them are supported by experimental evidence. This leads us to a quiet truth that scientists rarely emphasize in public. Time travel is not forbidden by the equations of physics, but it may be forbidden by the deeper structure of reality itself. Stephen Hawking once proposed what he called the chronology protection conjecture. He suggested that the laws of physics might prevent time machines from forming, in order to protect the universe from paradoxes. In simple terms, reality may be built in a way that does not allow its own history to be broken. There is also a more subtle and unsettling idea. Even if backward time travel were technically possible, the amount of control required to navigate space-time precisely enough to reach a specific moment in the past might be far beyond any civilization, no matter how advanced. Space-time is not a smooth grid. It is dynamic, curved, and constantly shifting due to the motion of matter and energy throughout the universe. Trying to target a precise past event would be like trying to hit a single moving grain of sand on a stormy ocean. Then there is the question of information. All real systems in nature obey the second law of thermodynamics, which says that entropy, or disorder, always increases. Time has a built-in direction, not because of clocks, but because of how physical processes unfold. Broken cups do not reassemble themselves. Smoke does not return to the cigarette. Heat does not flow from cold objects to hot ones on its own. This irreversible behavior may be telling us something fundamental about the nature of time itself. Some physicists believe that time travel to the past is not just difficult, but incompatible with how information and causality work at the deepest level. Yet even with all of this, the universe continues to surprise us. Quantum physics introduces its own strange relationship with time. At very small scales, particles can behave in ways that seem to blur the line between cause and effect. Some experiments suggest that future measurement choices can influence how particles behaved in the past, although not in any way that allows messages to be sent backward in time. This does not mean time travel is happening, but it does suggest that time is not as simple or one-directional as our everyday experience makes it feel. So what is the truth about time travel that scientists do not usually say out loud? The truth is that time travel is not a single yes or no question. Traveling into the future is already real, but currently impractical on human scales. Traveling into the past is not ruled out by mathematics, but it may be ruled out by nature itself. And most importantly, time itself is not what we intuitively think it is. It is not a universal river flowing at the same speed everywhere. It is a flexible dimension that bends, stretches, and shifts depending on motion, gravity, and energy. When you understand this, time travel stops being a fantasy story and becomes something deeper. It becomes a reminder that reality is far stranger and more subtle than our instincts suggest. We are all already traveling through time at 1 second per second, carried forward by the expansion of the universe, the motion of Earth, and the irreversible flow of physical processes. We cannot go back, but we can slow down, speed up, and experience time differently depending on where we go and how we move. In the end, the real mystery of time travel is not whether humans will ever build a machine to move through time. The real mystery is why time exists at all. Why the universe has a direction. Why moments pass instead of repeating. Why we remember the past but not the future. These are questions that science is still quietly working to understand. And as we continue exploring them, we may discover that the deepest truth about time is not how to escape it, but how to live meaningfully within it. If this exploration changed the way you think about time, share your thoughts in the comments. And for more calm, thoughtful, and deeply human explorations of science, technology, and the future, subscribe to Cognara. I'm Michael, your science and technology educator. And I'll see you again, here on the Cognara YouTube channel.